in this video, I'm going to go ahead and continue from the last, and I'm going to go ahead and I'm going to freeze off the red line in my detention ponds. All right. Now, as I said before, these contours don't look correct in this area, so I'm just going to go ahead and delete the feature lines that I created from before. And I'm just going to use the offset method of just a regular polyline. So I'm going to offset 4 feet. Sometimes grading plans and feature lines don't always work as you wish, and you have to do it the manual way. So I'm going to offset 4 more feet. So that's 72, 73, 74, 75, 76. And then I'm offset 10 feet and make that my 77 contour elevation. So that's typically how I would normally do it, because when we're creating ponds, we are wanting them to create specifically how it looks. Now, you may want to go ahead for volume purposes. Right now, that says 72. All of them say 72, so that would be a 73. And my properties manager's up. That would be a 74, 75, 76, and 77. All right. So the next thing that I want to do is I want to start with my storm pond or my storm system. And we still have to work on our grading. So first I'm going to go ahead and lay out a storm line, since we're still in that idea of working on storm. And then we'll do the grading, because I want to make sure that everything grades to the storm pond. The first thing that I'm going to do is I'm going to create a 3D polyline. So in my command prompt, I'm going to type in 3D poly. The reason I'm using a 3D polyline is because I'm going to create a network based on an object. So my start point is going to be, I'm going to hit shift, and I'm just going to pick a point out here and another point out here and a point in between the curb and the sidewalk, and I'm going to bring it to inside the pond, okay? And then I'm going to hit escape. The reason I did that, I created 3 vertexes, and these vertexes will be my inverts of my pipe. So the first vertex, if you come over here to your properties, and if you don't have your properties, just as a reminder, if it looks like this, type in PR to the properties command box. Now, I'm just leaving this on layer 0 because I'm going to delete it later. So vertex 1, I'm going to arbitrarily pick at least 5 feet below the existing ground. The reason I'm picking 5 feet is because I have to have cover over the pipe, and I have to have, typically we have at least 5 foot depth to the first invert for cover and for the size of the pipe. Okay, cover over the pipe means how much dirt is sitting over the top of the structured pipe. So I'm going to say, if it's a 75, I'm going to say my invert, my first invert is going to be a 70. So I'm going to say 70. My second invert, and I'm arbitrarily doing this. If I needed, what I would need to do is go to annotate, and I'm going to dimension out just to get the lengths from this endpoint of that line. I'm going to change that color too, just so I can see it a little bit easier. We'll change it to cyan. No, we'll change it to green. Got to pick a better color. I'm going to do orange. All right. So I'm going to figure out what the distance is from this endpoint to this endpoint, from this endpoint to, and these are when we start to do the calculations, these are going to be, they will be modified. But the typical slope we have on our pipe here in Florida, because we're so flat, let me move this out of the way, since we're so flat, is about 0.25%. So I'm going to get my calculator open. So let me do that. Calculator. We'll get that open while we're working. And the first thing I have, if I start upstream at a 72 and I'm going downstream at 0.0025% times that 28 feet, that gives me the invert here. So I'm going to say 70, not 72. 70 minus parentheses, 0.0025, that's the slope of the pipe, times 28 feet. So the invert here is going to be 69.93. Let me move this out of the way. So if I click on this next invert, it's going to be 69.83. That's what my calculator said. 69.93. All right. Now, the next thing that I have is I've got 69.93 minus parentheses 97, and you can do either 97 times 0.0025 or 0.0025 times 97.77 times 0.0025, doesn't matter. And that's going to be 69.68. So 69.68 will be the next invert. So vertex 3 is 69.68. Double check. 69.68. All right. And my last, I'm going to subtract minus, and I'm going to go 55 feet times 0.0025, and that's the slope. And that's going to give me a 69.5. And I'm just rounding these to make it a little bit simpler. So I'm going to change that last invert to 69.5. All right. Now I can get rid of these these dimensions because those are just to help me calculate. Now I've got a pipe that it goes from 70, 69.93, 69.68, and 69.5. The next thing I want to do is I want to go to the pipe network, and I'm going to create a pipe network from the object. So I'm going to select the pipe, and notice the arrows. This is the direction I want to go. If it is going the wrong direction, hit reverse. But it is going the correct direction, so I'm going to click on OK, or just hit Enter. I'm going to call it Storm Run 1, and I'm going to change the parts list to Storm Sewer. Now, the next thing is I'm going to change the pipe type, and I'm going to say it's a 24-inch concrete circular pipe. And the structure that I'm going to use isn't the head wall, but it's going to be typically I either use a 48 concentric cylinder structure, or I'll do a concentric cylinder structure with the NF. I'm going to do the NF this time, no frame, just to show the difference, because I did the other one in the previous video with a structured top. Now the surface that I'm going to use is going to be road 1, and the alignment that I'm using is road 1. The reason I need this is when the contractor needs to build it, it'll tell me the offset from the center line to the center of the structure. I'm going to use the vertex, and I'm going to use the invert. Now, some people use the crown of the pipe, this part here, to make the design hydraulically efficient, but I go ahead and use the invert to make my life a little bit easier to design. And then I'll go back and design for the crown to be more hydraulic efficient. But I'm going to use the invert here for the first go around. I'm going to click OK, and what it does is it creates these structures. Well, I'm going to use an FDOT index structure, type 2 in the sags, and a storm manhole here, and a mitered end section here. So I'm going to click on the first one, I'm going to right click, and I'm going to say edit structure style. Oh, I'm sorry. Yeah, not style. It's been one of the, I'm going to say structure properties, the structure properties, not the style. So in the structure properties, I'm going to change the name to S-1, and I'm going to change the style to a type 2 because that's one that is for a SAG here in Florida, FDOT type 2. Apply and OK. Now, I need to rotate this structure so that it, make sure my snaps and my ortho is off, because I need this edge to lay against this line. And if I do that, I need to turn my help off, I could actually go P-line and create a P-line from the center of this object perpendicular to the structure itself. And then I can move that line that I just created from the endpoint here and do perpendicular to here. And then what I'll do is I'll just stretch this, I'll move this from this circular endpoint and snap it to the endpoint here. And it'll be perfect, perfectly aligned. Now, I'm going to use the same one, and I'm going to move that from the endpoint here, and I'm going to do perpendicular to here. I need to grip edit, use the circle to rotate it about, and I'm going to move it from the endpoint to here. All right. Oops, I used the wrong one. Now, the other thing you notice, I forgot, and when I moved that, I need to undo. I lost my structure. So I'm going to move this to the endpoint here. Move that from the endpoint. Be careful when you're working with these, and you'll see what I had just done to perpendicular to this line right here. Now, so I know exactly where that center hole needs to be. Now, if you look at this line right here, it'll give me a length of 5.5 feet. So the center mark, if you look at the DOT index, that center of the manhole lid is actually 5.5 feet off of the edge of pavement. So now what I have to do is change this one, select it, right click, structure properties, change it to structure name is going to be S-2. I like capital letters, S-2. And I'm going to change to type 2. Apply and OK. Now I have to select it and use the dot to grip edit it to make it perpendicular. And I'm going to take the center point and I'm going to go to the end point of that line. Okay, and then you could just delete the miscellaneous line. Now on this one, I'm going to swap its part. I'm going to do structure properties, and I'm going to say S-3, and I'm going to use a storm manhole, not a sanitary manhole. Apply and OK. And the last one I'm going to select, and I'm going to say structure properties. And I'm going to say MES, mitered end section 1, and I'm going to change it to a 4:1, and I'm going to make it a 48-inch pipe because I'm going to assume I did the calculations and it's a 48-inch pipe that's needed. Apply and OK, and I just pull this back. It's going to my snaps, so I'll just go ahead and leave it as is for right now until I figure out where that invert elevation is. Now the other thing that you can do is go ahead and click on the storm structure or the storm pipe and swap properties and say that's going to be an 18-inch pipe. Select the next pipe, right click, swap part, and that's going to be, we'll leave it as a 24, and the last one we'll say is a 48-inch pipe. Swap part. Now when you're doing this, as I'm talking about this, what it's actually doing is the engineer will have to come out and he'll have to figure out the drainage area that's going to each one of these structures and figure out the size of the pipe. You can do that by looking at the analyze, and you can pull it down and you can launch the storm sewers. This allows you to design the pipe structures and the inlets in here and import it you can import the DXF into this and draw the structures. Now, you can figure out the pipe sizes. I'll do a video on that for the hydrology and hydraulics class, and I may upload it here, I may not. But we're going to be using the rationale method for designing the pipes. Now, that's all inside of Civil 3D. So for the design of the storm pipes, you would want to go to FDOT, their website. So I'll show you that here. So you might want to go to FDOT's website. So you go FDOT storm drains. And you can go to their drainage book here, and it'll tell you how to design the inlets and the structures on that. They use the TR55 and the rationale method. They'll use the rationale method on the storm structures, but for the overall sizing of ponds, they'll use TR55 if the size is within reason. For example, less than 10 acres or such. So the hydrology method of it, for the rationale method, Q equals CIA, where the C is the runoff coefficient, which is basically how much impervious area and how much impervious area you have affects the runoff coefficient. The I is the intensity factor based on the time of concentration of it, and the A is the area of the drainage basin that's discharging to the inlet. Now, I recommend going to the land development handbook that we're using for this class and review the chapters on storm design, both for detention ponds and for the storm inlets. All right. So we've got one line done. Now we're going to go ahead and have a second inlet set, and we're going to connect to this group. So all of these pipes need to be designed and need to be imported into our structure. So I'm going to go ahead and create another 3D polyline, and I'm going to start here on this low point. And I'm drawing it as I would drain to it. And it's going to connect to that center point. So on this one, I take a look at what the spot grade is. So elevation again is at a 75. So on this one, what I would do is I would go annotate, and I would get the distance here, and I would get the distance here, and I would set the inverts. So my first invert is going to be a 70 because it's about 5 feet below. So I'll go ahead and use 70. My second invert is going to be the 6993 because it's going to be the same distance for this one as it is over here. My third invert is going, if we use the 6993, clear that out, 69.93 minus 0.0025, because that's our slope, times 142, that's going to give us 69.5. So the invert that we had this one set at, so that elevation is going to be, well, we've tied it into 69, so it needs to be 69.5. All right. Now, because this one is already lower, we have to make the pipe here, this structure, if we look at, all I did was select it and right click, we have to edit the structure properties. And we need to make sure that the sump and the inverts are set. So what I'm going to do is I'm going to go ahead and I'm going to create all of the structures, and then I'm going to go back and make sure everything is correct. So I'm going to click on the Home tab, Pipe Properties, Create Pipes from Object. It's going in that direction. Click OK. So we're going to do Storm Run 2, Storm Sewers. We're going to start with an 18-inch pipe. Structure type. Now we're going to use Road 2. Road 2 for the alignment. Use the vertex, and we're going to use it as an invert and go OK. We'll have to change these. Right click, and we'll go structure properties. We'll call this S-4. We'll do this as a type 2 inlet. Apply and OK. We'll do this one. Right click. Structure properties. S-5. Type 2. Apply and OK. And we don't have to do anything with this one because it's already set. Now, on this one, we have two structures we are connecting to. We actually created a second system. So this one is on top of this. So what I'll end up having to do is actually go back and delete that one. Now, it's not going to let us tie into this structure because it's two separate runs. So what I could have done, and I'll show you this now, is I can click on one of these. I'll delete the labels. I can click on one of those and I can edit that pipe network. And I'll get this toolbar up. Now, what I want to do is I am going to have, since I'm working on this structure, Storm Run 1, I'm going to come over here and I'm going to change that to a 48-inch manhole or conical structure, and I'm going to change the pipe to an 18-inch. Now I'm going to pull, it's thinking. Now I'm going to pull this down. It won't let me. I should have, because I've got it already set, I'm going to be setting structures and pipes. And I'm going to be going upslope to downslope. Or I can go downslope to upslope. So let's take a look. I'm going to go ahead and click on that to create a structure pipe. It's not letting it go. Let me do that again. Right click. You can right click and edit network. And, oh, I should have read the command prompt line. Specify and insert structure. So I'm going to put one here and I'm going to connect it to here. And it automatically connects it. So what I'm going to do on this one is I'm going to go ahead and delete this line out, delete my polyline out, because I cannot create the structures unless I'm all connected. So I don't want two runs. All of this is going to be one run. So on this one, I'm going to change that property, structure properties, and I'm going to call it S-6 because I'm going to have, this is 3, these two over on this side. Sorry. The two that are going to be over here is going to be, if this is S1, S2, S3, we're going to have a structure 4, structure 5, so this will be structure 6. Right click and structure properties. So we'll call this S-6. And this one is going to be, I'm going to create this as a V inlet. Apply and OK. And I'll take this and I'll rotate it. And I'm going to move it to this edge here. All right. Now, the other thing that you need to look at is the inverts. I'm going to wait and do the inverts last. The next thing that I want to do is I want to go ahead and add in additional structures. So I closed that, but I'm going to have to open it back up. And I'm going to edit the network again. I'll get the same information, but now it accesses this point. It says specify the location. So I'm going to Shift I'm going to put it on the property lines, and I'm just using my O snaps. And I just escaped. See the little, it looks like a light bulb. It's orange and it has a circle with 4 lines coming out of it. That means I can connect to something, okay? And then I'm going to hit escape. I just keep closing down the panoramic box by hitting X. Now on this one, I'm going to change, right-click, Structure Properties. I'm going to do S-4, Type 2, Apply and OK. Now I'm going to move this up and set it at the edge. It needs to be on the property line, so I'm going to go perpendicular. And this one I'm going to change, right-click, Structure Properties. So that's S-5, and it's going to be a Type 2. I recommend looking in DOT's index to review these types of structures. Now I'm going to click on it. I'm going to rotate it around. Click on it. Select the dot, and I'm just rotating it with my mouse. And I'm going to move it to the edge. And I'm going to do perpendicular to this line, because I want it on the lot lines where my low points are. And notice how it's not perfectly at that edge. That's what I did before. I went and used just a polyline at the intersection of this point and use nearest, and I can type in 5.5 and get exactly where I need that, so I can go to the end point of that line. To here, and now it's perfectly 5.5 feet away. Now I'm going to stop the video here, and in the next one I'll show you how to change the inverts of these pipes. When you do a 3D polyline, the inverts are set based on the 3D polyline, but when you draw, you have to set up either a rules, or you have to set them individually. So I'll show you that in the next video.